Worksheet 12b with the same stress block in worksheet 12a and c. Now the question asks to determine the maximum shear stress at this point and show the orientation of the plane on which they act. So similar, we have write down sigma x equal to negative 1400 psi. We have sigma y equal to plus 1000 psi, and tau xy equal to negative 500 psi. So maximum in-plane shear stress, we already have equation to do. So maximum shear stress, and that we have tau max equal to square root of sigma x minus sigma y over 2 square plus tau xy. And if you have that, remember in worksheet 12a we also have that number here, 12 minus 1000 over 2 square plus negative 500 square. And that we already have it. Tell A, you have this because sigma 1 equal to sigma average plus tau max, and the second component is tau max equal to 1300, and sigma 2 equals sigma average tau max also 1300 in the component tau max in there. So if you plug in correctly, of course, we have tau max equal to 1300 psi, and that is the first answer we have. First answer. And at tau max, we had the normal stress is sigma average, and we also define that in worksheet 12a. So just right here, sigma x plus sigma y over 2, plug in negative 1400 minus 1000 sigma y divided by 2. So you have that a plus here. So it's 400 divided by 2, 200 negative. So you have that sigma average equal to negative 200 negative 200 psi. So we have max and associate tau max and associate sigma average. We can go ahead to find out the orientation of the maximum shear stress. So orientation of maximum shear stress. And that is theta s. So we already have equation tangent of theta s. If you recall, use reference data card or the lesson note. So you have that equal to sigma x minus sigma y over 2 for the numerator divided by tau xy for the denominator. And we plug in that and inverse tangent. So you have this is 2 theta s. It had to be 2 theta s. So that theta s equal to half divide inverse tension of plug in the number sigma x negative 1400 minus 1000 divided by 2 divided by tau xy minus 500. So from that, there we have theta s equal to negative 33.7 degree. And now you know what a negative mean. In the worksheet 12a, we say positive 1131 degree. Positive mean counterclockwise. And this is opposite. Negative mean clockwise. So here, negative mean clockwise. So how to present the stress blocks for maximum shear stress? So let's put the block here. So we have the where the original axis x. So we have axis at horizontal here, that original axis s. And this angle rotate clockwise 33 degrees, so that it become 33 degrees. So we have here, and it clockwise. So that angle there, clockwise 33.7 degree. And that is the first plane for the maximum shear stress. So from that we can draw the plane that perpendicular to that axis. As you can see there, it form a right angle here, and then of course the other just square, make a block, square block that you have. Then tau max, so we have tau max here, and of course we also have tau max opposite, and we have tau max this way, and of course tau max that way to make it in equilibrium. And at tau max that you just draw equal to, we already find out, negative 200, right? So no, 1300 psi. So 1300 psi, and then sigma average negative 200. So that is everywhere in negative 200 for on the plane. I have here a negative, so 200 psi. That is sigma average 200 psi, sigma average 200 psi, and of course as you can see, negative in compression, and all the other ways that you have it there. So with that, we can be able to find out the plane for orientation of the maximum shear stress and the tau max and the average. With that, we done for this worksheet 12b.